Hi there, we're going to continue our discussion of continuity, and in this video we're going to talk about left and right continuous. So what does it mean to be left or right continuous? I mentioned at the end of my previous video is essentially when the limit from the right is the function value, then you're right continuous, and when the limit from the left is equal to the function value, then you're left continuous. So that's essentially what this definition is saying. So you're continuous from the left or left continuous if your limit from the left is equal to the function value, and your right continuous if your limit as x goes to a from the right is equal to the function value. And then continuity on an interval, then we can choose to use brackets or parentheses if it's right continuous or left continuous. So if something is left continuous, we will include that left endpoint. If something is right continuous, we would include the right endpoint. So back to the graph that we had in one of the examples in the previous videos. Determine the intervals of continuity for the function shown. So we have to see, okay, so looking at this is going to be, notice that here at 0, there's nothing coming from the left. And so this function is continuous at 0 only from the right. So we can say f of x is right continuous at x equals 0. Right? Why? Because the limit as x goes to 0 from the right of f of x is equal to f of 0. As x goes to 0 from the right, you're equal to the function value, which is 1. So that means we would include 1 there. And up here, notice this continuous, left continuous at 2. So we will say f of x is continuous on what intervals? So I'm going to say 0 to 2. Right? So it's right continuous at 0, it's left continuous at 2. And then what about from 2 to 3? Now here we have an asymptote, so that likely means that we are going towards negative infinity, right? So we never touch that value of x equals 3. So it's continuous on 0 to 2, then it's continuous on not including 2 to 3, not including 3, right? Notice that here, this is not, as x goes to 2 from the right, we are not equal to the function value. So f of 2 is 2. So the reason that that's not included is that f of 2 is equal to 2, but the limit as x goes to 2 from the right of f of x is equal to 4. So it's not right continuous. So I don't include that endpoint. And at 3, f of 3 doesn't even exist. So we can't include that. And then so I guess I should be maybe using commas. Here I'm going to list the intervals again. So let me make little stars, I guess. And then my other interval will be from 3 to 4. And what happens at 4? Do I include it or not include it? Not included, right? Is definitely not continuous there. There's a removable discontinuity, so I don't include it. And then from 4, not including 4, because of the same reason we don't include it there, to 5. What about 5? Do I include it or not include it? It is included, right? Because it is, which way? Continuous. Yeah, left continuous. The limit as x goes to 5 from the left equals f of 5. And so those are the intervals where the function is continuous. Normally, you will say f of x is continuous. CTS is my abbreviation on, and you will just list the intervals 0 to 2, comma, 2 to 3, comma, and then 3 to 4 not included, and then 4 to 5 included, because now we're talking about is the left continuous, right continuous, and so we get to include the values. An application of continuity in left and right continuous that comes up quite a bit is finding constants so that the function is continuous everywhere. And so, for example, here, determine the value of the constant k so that the function is continuous on the entire real line. So I have my function is f of x is 3x squared minus 1 when x's are less than 1, and 4x minus 5k if x is greater or equal to 1. So we're looking for that value of k so that we don't have a break in the graph or a removable discontinuity, right? A hole or a jump in the graph. So how do we find the k? And this is where the continuity checklist comes in handy. So let's write down again what our continuity checklist is. Anytime you want to see if a function is continuous at a point, you got to check the 3 conditions, right? The first one is that f of a exists. 2, that limit as x goes to a has to exist. And again, what this means is that the limit as x goes to a from the left has to equal the limit as x goes to a from the right. And then the third condition, that the limit and the function value be the same. So f of a has to equal the limit as x goes to a of f of x. So those 3 things have to happen for the function to be continuous at a point. So where do we have a risk that this function f of x is not continuous? So let's look at them. So the first portion is 3x squared minus 1. That's a parabola. Parabolas on their own are continuous. And 4x minus 5k, regardless of the value of k, this is a line. So and lines are continuous. So I have 2 continuous functions, but I'm piecing them together at x equals 1. So 1 is where we risk this function's not being continuous. So x equals 1 could make f of x not continuous. But we want it to be continuous. So we want to find the value of k that will make it so that the limit essentially is the same from the left and the right. And so how do we find that? And let me just show you real quick graphically what that means. So I've graphed this with k equal to 1. So if k is equal to 1, right, then that means that I have y equals 4x minus 5 is the line. So notice now that my function then has a jump. So according to the function, this will be open and this will be closed. And so, but this is not continuous. So k can't be 1 because when k is 1, f of x is not continuous. So what we want to do is find the k, find the correct k, so that this doesn't happen, so that we don't have a jump. So we want this solid dot to move up here and continue. So find the correct value of k so that there's no jump or hole or anything like that, so that there's no discontinuity. So that's what we're going to do. So let's bring in the function again, and we're going to just really go through the continuity checklist. So here's our function. So our a is 1, right? Because as we said, that's where we risk the function not being continuous. So I'm going to check everything for a equals 1. So the first thing is, does f of 1 exist? So where are we allowed to plug in 1? Where we see the equals. So let's see, f of 1 equals 4 times 1 minus 5k. So we can say, yes, it exists. I can plug in 1. So it's just 4 minus 5k. So that's what f of 1 equals. 2, does the limit as x goes to 1 of f of x exist? Well, we want it to exist. So we want we want the limit as x goes to 1 from the left of f of x to equal the limit as x goes to 1 from the right of f of x, right? We want this limit to exist so that the function is continuous. So let's look at what is the limit as x goes to 1 from the left. From the left, which function are we following? If you're to the left of 1, you're smaller than 1, which means you're less than 1. So we're following 3x squared minus 1. So the limit from the left means of f of x means that we're following the limit as x goes to 1 of 3x squared minus 1. And plug in the 1, so I get 3, 1 squared minus 1, so what's that? 2. And the limit as x goes to 1 from the right of f of x, then we're following the other function. The other function is the line 4x minus 5k. So plug in 1, so we get 4 minus 5k. You're plugging 1 for x. Remember, we're looking for the value of k, so there's nothing to plug in for k. X is going to 1, so only the x gets replaced by 1. So we want these to be the same. We want them to be equal. So that's where our equation is going to come in. So set them equal to each other. So I'm going to have 4 minus 5k equals 2. And now notice that this is going to allow me to solve for k. So bring the 2 over and send the k to the other side. So 4 minus 2 is 2, right? And then moving the k over, divide by 5, so 2/5. So that means that x equals to 2/5 will make the function continuous. So the value of k equal to 2/5 makes f of x continuous on the entire real line, minus infinity to infinity. Cool. So I want you to try a problem on your own. So go ahead and write this problem down and try it on your own. I know it's a piecewise function with 3 pieces. And so looking at these, we have a risk of the functions not being continuous at 2. So you could potentially not be continuous at 2 because there's a break in here. And you also have a risk of not being continuous where else? At 3, right? So then those are the values that you're going to check. So you're going to have 2 different things going on. You're going to be checking the list, the continuity checklist for a equals 2 and for a equals 3. And so as you go through, this one is a little bit complicated, but if you follow the continuity checklist, it should come out. So the hint that I'm going to give you is that by the time you've done the continuity checklist for 2 and for 3, right, those split points, you're going to end up with a system of equations that you get to solve. You can and you use your algebra ways of solving systems of equations, either by elimination or substitution, and then you'll come up with the values. What are we looking for in here? You're trying to find values of a and b so that the function is continuous on the entire real line. So that's what we're looking for. And yeah, so have at it and then let me know how you do.